When the rod is moving upwards, it will push the contacts to give signal to the circuit breaker to trip. Bismillah ar-Rahman ar-Rahim. The tank of oil-filled distribution transformer is not designed or manufactured or operated to be a pressurized vessel. What does this mean? It needs us to understand what is meant by pressurized vessel. Pressurized vessel means there is a space, there is a container where the pressure inside the container is much more than the pressure outside this container. So it will have special design and manufacturing to be able to withstand this difference in pressure. There are so many popular applications for pressurized vessel. The LPG cylinders, liquefied petroleum gas, which are used for domestic applications. Also diving cylinders, which are used by divers deep underwater. Some cylinders for liquefied gases like ammonia, which are used for particular applications. Air compressor, also an example of pressurized vessel. Spaceship environment, also pressurized vessel. But maybe the most interesting example of a pressurized vessel is the aircraft cabin. It has the special design, fabrication, operation, everything. Now back to our transformer. Our transformer is not, as we said, designed or built or operated to be a pressurized vessel. It's only supposed to withstand small overpressure. And in case of high pressure, according to the abnormal operation or fault conditions, there should be a way to protect this transformer from explosion. Explosion of a transformer is very dangerous. It can affect humans, animals, environment, assets, everything. And there are so many ways to protect this transformer. For power transformers, there are so many sophisticated aids and tools to protect the transformers, like buckles, relay, and other things. But for our distribution transformer, oil-filled distribution transformer, the most popular thing is to use the pressure relief valve. Pressure relief valve is used in so many applications, especially in water networks. Whenever there is a need to reduce the pressure, which is supposed not to be built up, these pressure relief devices are used. Pressure relief valve, in its simplest construction, is like this one. Rod loaded with a spring, and there is a gasket which will come between the pressure relief valve, PVR, and the transformer tank. And whenever there is pressure inside the transformer, this will push against the spring force, and this lid will come up, and there will be a route for the gases inside the transformer. This is the rod, and this is the spring, and this is the cover, and it has a sealant or gasket here, and also there is a gasket between the PVR itself and the tank of the transformer. And normally this PVR has a special design made of brass or aluminium, and sometimes with painted aluminium, because this PVR is supposed to withstand tough conditions, very high temperatures. And whenever this is pulled up, there will be a way for the gases to go out from the PVR. Sometimes for this PVR, it can come like this without contacts. Sometimes it comes with contacts to provide a protection to trip the circuit breaker, and in that tab you will find like a small extension of the PVR where the contacts are enclosed. When the rod is moving upwards, it will push the contacts to give signal to the circuit breaker to trip. And sometimes this pressure relief valve is equipped with a tube or cover to lead this extra gas and oil away from the transformer to a safe place. So back to the pressurized vessel concept. This transformer is not a pressurized vessel. This PVR, pressure relief valve, is to maintain the pressure inside the transformer same as the outside atmospheric pressure. Whenever there is an excess pressure inside the tank, this will provide a force which will move the rod against the spring force, and will release these extra gases. As we explained earlier, there is an air cushion above the oil level in the transformer. During faults and abnormal conditions, there will be an extra heat generated inside the transformer. So this air, this gas inside the transformer will get heated. The simple equation which describes the physics of the gas is PV equal nRT. P is the pressure, V is the volume, N is the number of moles, R is the gas constant, and T is the temperature. When this T increases, the pressure and the volume of the gas will increase. And when the temperature increases significantly, like in fault conditions, this pressure and volume of the gas will increase, and if it is not resolved, explosion will happen, and this is very dangerous. So this pressure relief valve will provide a route for this extra volume and extra pressure inside the transformer. It will provide a relief, and that's where the name comes from, and consequently protects this transformer from explosion. In the next episode, inshallah, we'll continue with the transformer accessories. To start after that with the tests carried out on transformer, whether type test or routine test, with the practical examples taken from the factories themselves.